All right, today we're going to dig into a story that's, well, it's pretty wild. It's about a substance that looked like it could be a miracle cure, but it ended up challenging the very foundations of the medical system. It's a fascinating tale of discovery, fear, and a chemical that just refused to play by the rules.
So let me ask you something to kick things off. What if I told you there was a liquid that could pass right through your skin? I mean, just soak in, carrying whatever it touches along with it. Sounds like something straight out of science fiction, right? Well, it's real. And this is where it gets really interesting. This stuff has a list of properties that are almost unbelievable. I'm not just talking about passing through the skin. It can cross individual cell membranes. And here's the kicker, it can cross the blood-brain barrier. You know, that super selective gatekeeper that protects our most important organ from all the bad stuff. Almost nothing gets through that. Okay, so what is this mystery liquid? It's called DMSO, which stands for dimethyl sulfoxide. And its backstory? It couldn't be more ordinary. It's a simple, colorless liquid that was just an industrial byproduct from making paper. Yeah, from wood pulp to something that could totally change biology. Crazy.
So, to really get the whole story here, we've got to jump in a time machine and go back to the 1960s. This was the moment, a period of just explosive interest, a time when this simple little solvent was being talked about as a potential miracle in a bottle.
Now, DMSO was actually first created way, way back in the 1800s, but then it just sat on the shelf for 100 years. Nobody did anything with it. Then, in the 1950s, a little medical interest started to bubble up. But by the 1960s, that little simmer turned into a full-on, raging fire of research and excitement.
And what researchers were finding was, frankly, astonishing. They discovered DMSO had these powerful anti-inflammatory and pain-reducing effects. It could even protect cells when they were frozen, making it what's called a cryoprotectant. And of course, that incredible ability to penetrate things. And it even had antimicrobial properties. I mean, it seemed like it could do everything. So this led to its most revolutionary idea, using it as a kind of universal carrier. The thinking was, hey, what if you could mix other medicines with DMSO, and it would just shuttle them directly into the body's tissues? You could bypass the stomach, the liver, everything. This was its greatest promise. And as we're about to see, its biggest problem. But as you can imagine, this scientific marvel pretty quickly turned into a regulator's absolute worst nightmare. See, the very thing that made DMSO so special also made it incredibly, incredibly difficult to control. At first, the main concerns were about the side effects. People reported things like skin irritation, and, most famously, this really strong, distinct garlic or oyster-like smell on their breath and their skin after using it. Some people also got nausea or headaches. These were the first official red flags.
But here's the thing, and this is absolutely crucial. The real problem wasn't just simple toxicity. It was unpredictability. You just couldn't standardize how it would behave out in the real world. And here's why that's such a big deal. If DMSO carries anything it touches straight through your skin, well, what happens if your skin isn't perfectly sterile? It could drag bacteria, or maybe heavy metals from jewelry, or even leftover chemicals from your soap, directly into your bloodstream. For a regulator, that's a nightmare scenario. It's an uncontrollable, totally unacceptable risk. And this just perfectly captures the dilemma, doesn't it? It's a classic double-edged sword. On one side, you have this amazing substance that can deliver helpful medicine right where you need it. But on the other side, it can deliver harmful toxins with the exact same terrifying efficiency. Now, it's really important to get this straight. DMSO was never completely banned. In fact, it's still FDA approved today for some very specific medical uses, like treating a painful bladder condition called interstitial cystitis. So what does that tell us? It tells us this isn't some back alley quackery. It's a recognized tool, just a very, very restricted one. Okay, but was that unpredictability the only reason it was kept from being used more widely? The sources we're looking at suggest there was something else going on, a deeper, more systemic fear, a disruptive truth that DMSO brought to light. And this gets to the question that must have quietly terrified the entire pharmaceutical industry. Why would we spend billions of dollars engineering these complex drug delivery mechanisms when a simple, cheap solvent can do the job? I mean, the whole model of drug development is built on creating complex, patentable delivery systems. DMSO threatened to make a huge chunk of that obsolete, practically overnight.
Just think about it for a second. With something like DMSO, drugs could potentially bypass the harsh acid in your stomach, they could skip being broken down by the liver on that crucial first pass, and they could get rid of the need for injections or fancy pills. This wasn't just a new product. It was a fundamental threat to the whole established infrastructure. So, you see, DMSO ended up in this totally impossible spot. It was way too effective to just ignore, but at the same time, it was too simple to control, too versatile to slap a neat patent on for one single use. And honestly, it was way too cheap to generate the kind of massive profits the industry is built on. It just didn't fit the model. And this is where public perception becomes a weapon. Remember that harmless, but yeah, kind of weird garlic-like side effect? Well, that became the perfect tool for dismissing the whole thing. It's a lot easier to make fun of something because it makes you smell funny than it is to have a serious debate about its profound implications for cell biology. Ridicule became a really effective form of suppression. But here's the thing. Despite all the restrictions, the regulatory nightmares, and even the ridicule, DMSO never really went away. And its story, its legacy, it raises some really important questions about innovation itself. When you look at it, the story of DMSO follows this classic pattern you see with a lot of disruptive ideas. First, it's discovered, and everyone gets excited about its potential. Then, researchers and doctors start using it. But then, because it's unpredictable, the regulators step in and restrict it. Then its little quirks are used to ridicule and dismiss it. And finally, it's quietly preserved, kept alive by the people who use it for one simple reason: because it works. And that, right there, is really the core takeaway from this whole story. DMSO wasn't put on the shelf because it was a failure. It wasn't shelved because it didn't do what the scientists claimed it did. No, it was shelved because its unique properties, its beautiful simplicity, and its low cost just didn't fit into the economic and regulatory boxes of modern medicine. And so that leaves us with a much, much bigger question, doesn't it? The story of DMSO is a powerful case study for sure, but it really makes you wonder, how many other powerful ideas, incredible tools, or amazing discoveries might be sitting on a shelf right now? Not because they failed, but just because they didn't fit the system we've all built.